We started with the periodic table alkali metals or group 1 metals. Why we call them as alkali metals? Because they tend to produce alkali when they react with water. Next is the halogens. What are halogens? Group 7 elements are also known as halogen. The term halogen means the salt form. Group 7 are also known as halogens. The term halogen means the salt former. When they react with metals, they will form a salt. That's why we call them as halogen. When we check the positions, so first we have fluorine, then we have chlorine, bromine, and iodine. As it belongs to group 7, so if I draw only the valence shell or the last shell, fluorine will have 7 electrons in the outermost shell, chlorine will also have 7 electrons, bromine will have 7 electrons, and iodine will also have 7 electrons in the last or the outermost shell. But what is the difference? Because it belongs to different periods, so fluorine having only 2 shells, so second period, chlorine we use 3 shells, so third period, but the total number of electrons in the last shell will be same for all. How these elements exist in nature? So these elements in nature we exist as a they're not in the same period, they're in the same group. The elements which are in the same group cannot be in the same period because they have different number of shells. For fluorine, there are 2 shells. For chlorine, there are 3 shells. For bromine, there are 4 shells. For iodine, there are 5 shells. So number of shells represent the period. Because they have different number of shells, that's why they belongs to different periods. But they have same number of electron in the outermost shell, so they all belongs to the same group, and that is group 7. So how they exist in nature? Fluorine is a gas. It's a pale yellow gas. Chlorine is yellowish green. Bromine is red brown. And iodine is, so bromine is red brown liquid, where iodine is black or purple solid. So as we go down the group, as we are going down the group, what we observe, the color intensity increases. The color will become darker as we go down the group. Then the reactivity, these are non-metals. So for non-metal, the reactivity means reactivity means tendency to lose, tendency to gain electron for non-metals. So tendency to gain electron, it is refers to the reactivity of the non-metal. So as we go down, what we observe the reactivity is decreasing. But why the reactivity is decreasing as we go down the group, you can check here. Fluorine is smaller in size. So when the fluorine will react, it can attract the electron easily. Chlorine is much larger in size compared to fluorine, so it will take time to attract the electron. Bromine is much larger, further it will take more time. And iodine, bigger in size, so it will also take greater time to attract, or it has a weak force. As the size is getting larger, the distance from the nucleus to the electron, outside electron, is getting greater, like the distance between the nucleus and the electron which is outside the atom, that distance is increasing. So as this distance increase, the force of attraction between the nucleus and the electron will decrease. So which of the atom can attract electron much faster or easily? So fluorine can attract electron easily.
Sir, why does the reactivity decreases in group 7?
Because the non-metals have a tendency to gain electron. These are non-metals. So non-metal, because fluorine is smaller in size, so electrons are closer to the nucleus, so it can attract the electron easily towards the nucleus. Where iodine is larger in size, so as it is larger in size, the distance from the nucleus is more, so attraction will get weaker. So it cannot attract the electron easily. That's why when you compare the attraction towards the electron, fluorine is having greater attraction or tendency to attract electron as compared to iodine. And for non-metal, the reactivity refers to tendency to attract the electron. That's how they react.
All right.
So as we go down the group, the reactivity decreases for group 7. What about the melting point? You can identify the melting points from the states. You can see here. You can identify the melting point from the states. You can see here. Fluorine is a gas. Chlorine is a gas. Bromine is a liquid, where iodine is a solid. So as you go down the group, the melting point will increase or decrease. As we go down the group, what happened to the melting point? So the melting point will increase. There is a reason for that, but reason why the melting point increases as we go, the same thing. Melting and boiling point both increases as we go down the group. You don't have to learn the reason, because that reason is related to a force which is called van der Waals force, and that van der Waals force increases as the number of electron increase. That's why it's not part of the syllabus, so I'll not go in detail of that van der Waals force. Just you have to learn a periodic trend. So as we go down the group, the melting point for group 7 increases. And the density for all the groups, because as we go down, the mass is increasing. So down the group, the density will always increase. Is it clear? These are the periodic trends which you have to learn. Halogens of group 7, which are also known as the salt former, they react by attracting the electrons. Because the mass increase, as the mass increase, density is mass present in a unit volume. So density will also increase. As you go down, the mass of the atom, the mass of the nucleus is increasing. That's why density always increases as you go down the group. You don't have to learn the reason for trend. They will not ask a reason. Just you have to learn the trends. Yes, you have to learn the color intensity, specific color. You have to learn the intensity of the color. Like what will be the color for fluorine, chlorine, bromine, and iodine. For group 1, you don't have to learn the color for group 1, the appearance, because all are metals, but you don't have to learn the appearance of the metal. Mostly metals are shiny, but the surface is tarnished due to the oxide layer. Copy this part. Tools exist. They exist as a diatomic molecule except group 8. Like example, if I say fluorine, so fluorine does not exist as fluorine atom, it always exists as fluorine molecule. Chlorine does not exist as chlorine atom, it will be chlorine molecule, bromine molecule, iodine molecule. And what kind of bond is there between them? Fluorine, because these are the non-metals, whenever even identical non-metals or two different non-metals, so they will have covalent bond. So they will share electron. Fluorine belongs to group 7, so it will share one. So the shared pair will
They
be
are
there.
diatomic atoms.
What?
They are diatomic molecules.
Diatomic molecule. Use the option raise hand if you want to convey anything, because they exist as a diatomic molecule sharing a pair of electron between them. Same thing how the chlorine exists. Chlorine atoms are larger in size as compared to that of fluorine. They also share a pair of electron. So one shared pair is there and 3 unshared pairs are there, and they will have a covalent one. Same thing for bromine and iodine. So how they exist? They exist as a diatomic molecules. Then about the reactivity, how we can identify that which one is more reactive, which one is less reactive. So keep in mind the most reactive halogen will displace less reactive halogen from its compound. So the most reactive halogen will displace the less reactive halogen from the compound. This is called, yeah, the displacement reaction. So when you have a compound, the compound will have two parts. If it's an ionic compound, then it will have metal and non-metal. So example, as we go down the group, we observe the reactivity decreases. So if you have fluorine reacted with potassium chloride, look, if an element, if a non-metal element is reacting with a compound, so what will happen? No, it does not happen, Salman. If it's an element is a metal, it will replace the metal. If an element is a non-metal, it will replace the non-metal. Metal cannot replace non-metal, or non-metal cannot replace metals. Yes, Hashim, you have a question?
No, sir, it was by mistake.
So what happens if the element is a non-metal element and you have a compound? So compound will have two parts. One is a metal, another one is a non-metal. So non-metal always replace the non-metal. So it will replace, if it's more reactive, it will replace chlorine. So as a result, the product will be potassium fluoride plus chlorine. If you have a non-metal element which is more reactive and it is reacting with a compound, so the non-metal will replace the non-metal, but to replace the other non-metal, the non-metal element should be more reactive. So in this example, fluorine is reacting with potassium chloride. So chlorine is a non-metal present in a compound. As we know, fluorine is more reactive, so fluorine will displace this chlorine from the compound, which will form potassium fluoride. It will form potassium fluoride and Cl2. Why it is not, why, what's the formula for potassium fluoride? How you can work out? You have to work out from valency. Whenever you're writing a formula for compound, you have to work out the valency and then write the formula. So potassium belongs to group 1, so its valency is +1. Fluorine belongs to group 7, so its valency or charge is -1. Whenever two valencies are same, the formula will be Kf, potassium fluoride. It cannot be Kf2. Why it is K, not Kf2? Because the valency of potassium is +1 and fluorine is -1. So whenever you write a formula of a compound, you should always work out the valency, and using a valency, write the formula. So fluorine reacted with potassium fluoride, as fluorine is more reactive. So fluorine, more reactive non-metal, it will displace chlorine. So it will form potassium fluoride. It will form potassium chloride and chlorine molecule. The second part is balancing the equation. The first part was writing the equation. The second part, because in exam you will always find the equation is having 2 marks. Why there are 2 marks for any equation? 1 mark is for completing a product, right? Completing or with the right product. The second mark is for the balancing. Now to balance this equation, you can take any element here in this one. So here we have 2 fluorine. The other side we have only 1 fluorine. For balancing, I cannot write the number down. That is totally wrong. I can only place as a coefficient. So I place 2. So when I put 2 here, fluorine is balanced. But when I place this 2, fluorine is balanced. But what about potassium? This makes potassium also 2. So if I put 2 here, potassium is also balanced. And chloride is also balanced. So first thing, whenever you write an equation, you don't try to balance in the beginning. First, you will write or complete the product, and then you will balance the equation. Yes?
Sir, I still didn't understand.
Which part?
The equation one, the valence.
Fluorine is more reactive than chlorine, so fluorine will displace chlorine. So as it will displace chlorine, so in place of chlorine, we have fluorine here. So what is the product? The formula of the product? So if fluorine is reacting with potassium chloride, first thing you should write a proper correct product. So fluorine will displace this chlorine. If fluorine will displace this chlorine, so means we should have a compound which contain potassium and fluorine. So what is the formula of a compound which contain potassium and fluorine? Potassium valency, it belongs to group 1, so it's +1. Fluorine valency is -1. When two valencies are same, we write as it is. So the formula for potassium fluoride is Kf. So we write Kf. Plus, as the chlorine is displaced, so we'll have chlorine. But these are non-metals. Non-metals except group 8 does not exist as a single atom. So how the chlorine element will exist? Chlorine will exist as a molecule. This is the first thing which is completing the equation. The first part. Is it clear? Completing equation.
Yes.
The second part is balancing the equation. How many chlorine are there on your right hand side? 2. So how many chlorine should be there on the left hand side? It should be 2. That is why I have substituted or put 2 here. So when I place 2 here, it means the chlorine is balanced. What about potassium? On your left hand side, you have 2 potassium. On the right hand side, you have 1 potassium. So you place 2. So potassium is also balanced. Is it clear?
Yes, sir. Yes.
So, and fluorine, about fluorine, we have 2 fluorine on the right hand side when we have 2 fluorine on the left hand side. So fluorine is also balanced. So all these elements of this equation is balanced in terms of fluorine and chlorine and potassium. So the more reactive halogen always displaces the less reactive halogen. If I say there was another reaction in which chlorine was reacting with potassium fluoride, what will be the product? Chlorine was reacting with potassium fluoride. So there is no reaction. Why? Because the chlorine, you can check the reactivity. Chlorine is less reactive. There is no change or no reaction. Why there is no? Because chlorine is less reactive than fluorine. So chlorine non-metal is not able to displace fluorine. That's why there is no reaction between them. So the most reactive halogen can displace or can react with less reactive halogen from its compound. Is it clear now? Copy this. Chlorine was reacting with potassium iodide. What will be the product if chlorine is reacting with potassium iodide? First thing, will they react? Is there a reaction between chlorine and potassium iodide? So when you check the reactivity, fluorine is more reactive than chlorine. Chlorine is more reactive than bromine. Bromine is more reactive than iodine. So iodine is least reactive. So it's less reactive. This one is more reactive. So first thing you should identify before completing an equation whether there's a reaction. So yeah, there will be a reaction. So chlorine is more reactive, so it will displace iodine. Then the formula of a compound which contain potassium and chlorine, that's potassium chloride or KCl, plus iodine is also formed, so that will be iodine. So the second thing is balancing the equation. So to balance the equation, we have 2 chlorine on the left hand side. So we should have 2 chlorine on the right hand side. So I substitute 2. So chlorine is balanced. We have 2 iodine on the right hand side, so there should be 2 iodine on the left hand side. So we put 2, iodine is also balanced. And when we substitute 2, so both sides we have 2 potassium. The equation is balanced in terms of potassium, in terms of iodine, and in terms of chlorine. If I give the state symbols, chlorine is a gas, potassium iodide is aqueous, chlorine is also, potassium chloride is also aqueous, and iodine is solid. And the question is, write an ionic equation for this reaction. So how to I write an ionic equation? So to write an ionic equation, I explain you the rule. The first thing, identify solid, liquid, and gas. Write them as it is. So on your left hand side, you can see chlorine is a gas. There is no solid on the left hand side, or there is no liquid on the left hand side. And the right hand side, you can see that iodine is a solid. So iodine is a solid. Then we cancel out the common ions in aqueous solution. So when you cancel out the common ion in aqueous solution, so what happened? Potassium is common, so potassium will cancel out with potassium. How I know that potassium chloride or potassium iodide is solid? I gave the question, that's why I know. If in exam, if it was solid or liquid, you cannot write an ionic equation. So this is a question I give. If I make a solution of a substance, then definitely it will be aqueous. So these type of question in which you don't know the state of a substance, they will specify before they ask to write an ionic equation. So potassium is common both sides. So we have iodide ion on the left hand side and we have 2 chloride on the right hand side, and this is an ionic equation for this reaction. Ionic equation normally it's written for aqueous substances. So whenever you have states in aqueous, then you can write an ionic equation. If something is solid, liquid, or gas, there is no ionic equation for that. In the question, I specify that potassium iodide and potassium chloride are aqueous, so that you can write an ionic equation. Is it clear? How to write an ionic equation for this reaction between the halogen with their compounds. Then what you will observe in this reaction, what is the observation? The observation is actually, look, if you can see, check, the chlorine is a gas. What is the appearance of a chlorine? Chlorine is light yellow in color. Iodide ion, chloride ion, yeah, yellowish green. Yeah, that's correct. So chlorine is yellowish green gas. What is the appearance of iodide ion? All these ions are colorless. Their ions does not, like example, fluoride ion, chloride ion, bromide ion, or iodide ion. All these ions are colorless. There is no color for them. So this substance is a colorless. The circled one is a colorless substance. So it's a yellowish green gas. And this substance is colorless. When it will form chloride ion, again, this is colorless. An iodine molecule as a solid. If iodine molecule is there as a solid, so what you will observe? You will observe black or purple solid. There is no white metal here in this example. There are no metals. It's black or purple solid form. So observation is the yellowish green gas, the solution yellowish green gas changes to as an ion, there is no observation like chloride ion, bromide ion, iodide ion. Alone, you don't observe anything until unless you add, like example, to have a visible observation for these ions, you should add silver nitrate or lead nitrate. Then it will give white precipitate, cream precipitate, and yellow precipitate. But in this question, we did not add anything. What happened? Chlorine molecule is reacting with two iodide ion. It's forming chlorine, chloride ion, and iodine molecule. So basically, chlorine molecule is a yellowish green gas. So in the beginning, we'll have yellowish green gas. But as the reaction progress, what we'll observe? We will observe iodine is formed, which is black or purple solid. But in exam, it depends on what is the state of iodine, because iodine can dissolve in water also. So you have to learn these colors of iodine. If iodine is solid, then it is blue black or it's purple or black. So iodine solid, it is black or purple. Iodine in water, in aqueous solution, and it is concentrated, it will be brown. Iodine in aqueous solution and dilute, it is yellow, pale yellow. Iodine in aqueous substance with starch, it is blue black. And iodine in alcohol, or organic solvent, it is pink in color. So these are the colors which you have to learn. Yeah, these are important things. You have to memorize these colors. It's related to paper 6 as well as paper 4. Yeah, there are other colors for halogen too. In different substances, they have different colors, Salman. But you have to learn